In this video, we're going to look at parallel arrays. Previously, we looked at regular arrays, and we saw how we could store multiple values in them. Now we're going to take a look at parallel arrays. So we're going to store a series of products and their prices. I have two arrays here. One is SKU for stock keeping unit, and it represents a unique identifier of every product. Down below, I've got another array, which is a double array called price, and I've lined these up so you can see them more easily. The 285 has a price of $1.98. The 496 has a price of $4.37. The 371 has a price of $7.99. The 485 has a price of $2.24. The 142 has a price of $4.48, and they line up so with the columns, the first column lines up with the first price, the second column lines up with the second price, and so on. And this is what we mean by parallel arrays. Now, you notice that the arrays are of different types, and this is why we use parallel arrays, because we couldn't store the price, which has a fraction in cents, inside an integer array. So we create a second array of a different type, and then we line them up position-wise. So in this little example, what I'm going to do is I'm going to get someone to enter a product ID, and they're going to use 0 to indicate they should stop. We're going to read it. If a product ID is greater than 0, then what we have to do is we have to look through the SKU array looking for that product ID. When we find it, we remember what position it was in, and then we find the price that's in the same position, and we know what its price is. Once we've read the product ID via this scanf, then we come down and we have to do a linear search. And the linear search is a very common algorithm, and it says, to find a value in an array, you start out and you look and you say, is the first member what I want? Nope. Let's look at the second. Is it what we want? Nope. Let's look at the third. Is this what we want? Yep. Okay, we found it in the third position. In order to make this work, I have to have an impossible position, because what happens if I don't find it? Well, if I don't find it, I have to have a way of indicating this. So I set my initial position where I'm going to remember the position to be -1, because you can never have a negative subscript. I'm also going to be using a flag variable to get out of the loop early, because as soon as I find it, there's no reason to keep looking in the loop. So I'm going to use this flag variable, keep looking, that will allow me to exit the loop early. I'm going to do a regular for loop to do the linear search, and I'm going to say if I equals 0, I is less than the number of products, and keep looking is true, increment I, and go through the loop again. Every time I go through the loop, I do this comparison, and I say if product ID is equal to SKU sub I, and the I varies every time through the loop, so I compare every SKU one at a time. When I find that they're equal, I set the position equal to I, which is the position I'm looking at in the loop when I found them equal. Then, because I found it, I don't want to look any further, so I set keep looking to be false. And that is going to cause me to leave the loop the next time around. At the end, I've either found it and I've put position to be a value of 0 or more, or I didn't find it and I hit the end of the array and position is a negative number. So I say if position is greater than 0, I know I found it, and I say my total plus equals price sub position. Now this price sub position is how I find the price. I know that the SKU was in whatever position value is, and I subscript the price array at exactly the same position, and it tells me the price corresponding to the SKU in that price. Now I'm simply going to add up all the prices of everything in a total, and I'm going to print it out down at the bottom. If it turns out that the position is negative, that means I didn't find it, and I print out a message that says that the product ID was not found. I do this as long as the product ID is greater than 0, and at the end I print out what the total equals. So let's just run this program to show how it works. I'm going to come down here so I can see my prices and things. And it says enter a number. So I'm going to say 142. And it says fine. And then I'm going to say 371. It says fine. I'll show you, if I put in an invalid number, it simply says it's not found. So that part works. And finally, I'm going to put in my 0. And it should print out the sum for item 142, which is 448, plus 371, which is 799. So it should be about 1247, something like that. Let's see what it says. Total is 1247. So it's right. That's how we can use parallel arrays to relate information about various products or anything that shares information of different types, and you want to be able to store them in irregular arrays. Okay, that's it.